Hello and welcome to the Geometry Notes. This is the first video for Unit 1 Notes, Foundations of Euclidean Geometry. And then Section 1 is called Euclidean Geometry. Okay, and so our objectives today, we want to identify and name undefined terms like point, line, and plane, and then be able to find the distance along a line. Okay, we want to analyze descriptions and diagrams and illustrate basic postulates about points and lines and planes. Okay, so the first thing that I want to talk about is some of this vocabulary here. And we have this guy named Euclid. He was totally cool. I wish he lived in our time and in Summit County so we could be friends, because Lord knows I could use it. And he lived around 330 BC. Okay, so he created a comprehensive study of geometry based on deductive reasoning and postulates, definitions, and theorems. So a postulate is something that we assume to be true. Okay, so we assume to be true. Okay. A definition means a formal statement declaring the meaning of a word. Okay, so we use these postulates, we use some of these ideas, the things that assume to be true, to then state a formal definition of something. And then a theorem is something that has to be proved. Okay, so we must prove it. Must prove to be true. Okay. All right, so let's talk about a couple postulates that we have in this class and for this section. And those are going to be what we call points, lines, and planes. Okay, so I'm going to identify what a point does. A point, and let me kind of zoom in here. A point shows a location. Okay, it shows a location. Okay, and its label is simply just a circle. Okay, if we wanted to name a point, okay, then we would say like a point and we would give it a capital letter. Okay, so like point A or point B. Okay, and then a line is a series of points strung together forever. Okay, so a series of points connected. Okay, and there's no beginning and no end. All right, so it goes on forever in both directions. So if I were to draw a picture of a line, I indicate that I have arrows on either side, and I would connect 2 points. Okay, so it has to have 2 points, and I would label that A and B. Okay, so then the label, if I were to name this, I would name it as line AB, okay, with a line above it with arrows, or I could name it as BA. Okay, it doesn't matter which one goes first when we're talking about a line. All right. Okay, now let's talk about a plane. Okay, and this is a surface. Okay, a surface with 3 or more lines. Okay, that defines a plane. Okay, and if I were to just kind of draw a picture here, all right, I kind of draw this little shape here so that it's like a view of a piece of paper. Okay, and on that paper, I would have 3 points, and actually it's 3 or more points, not lines, okay, that create this. All right, and so I would call this A, B, C, those points, and then, you know, we could connect those, we connect lines on those, okay? So that's the idea. All right, and so if I were to label this and name it, I would name it plane ABC. Okay, and that's what I would do. All right, so pretty standard stuff that you've seen before, and And we kind of talk about these definitions down here. Okay, a point has no dimensions. Okay, it's a location. We usually call it as an ordered pair XY, and we identify it with a single capital letter. Okay, so point A and point B. Okay, a line is one dimension set of infinite points. Okay, so a series of points that connect with beginning and no end. Okay, and sometimes we identified with a lowercase italicized letter or two capital letters. So the other way I could say this, let's say I had a point here or a line like this, and we'd call it like line M. Okay, so you can name it that way too. We would just say line M. Okay, so if there's a lowercase italicized letter there, tells me what a line is. Okay, a plane is two-dimensional. Okay, so no dimensions, one dimension, two dimensions, set of all points. A flat or level surface has no beginning or end, and identified with a capital or italicized letter. So another way we could do this is if you saw this and you saw that it had like, this big, R to it, we would also call it plane R. All right, so either way. All right, so one of the questions is how do we define distance? Okay, and we can define distance by using a number line. Using a number line. Okay, and when I use that hashtag, that means number. Okay, so if I wanted to count the distance between A and B, what I would do is I would compare it to a number line, and I would say, okay, point A goes down to -4, and point B goes to 4. So my question is what is the distance between -4 and 4? And so this is 8, okay? And that's how we calculate the distance between 2 points, okay? And we use a number line, all right? So if we connect 2 points of the line, we can find the distance, okay? So then let's do it for this one too. Okay, if we start over here at A, which is at what appears to be -9, and it goes all the way to 8, okay, what's the distance between -9 and 8? All right, well, the distance between 0 and 8 is 8, and then the distance between -9 and 0 is 9. So to calculate the whole distance, if I add 8 and 9 together, that's going to give me a distance of 17. Okay, and that's how we'd figure that out. Okay, all right, so then we have a couple of vocab words here, and one is the point existence postulate. And what it says is a line contains at least 2 points. So points that are on the same line are called collinear. Okay, so an example of that would be if I were to put these points, a series of points on here, and I'm going to call this J-O-E-P, okay, then I would say that points J, O, E, and P are collinear. Okay. Now the other thing, if we say that something is non-collinear, would be, and let's put that up here, underneath this, and say non-collinear. Collinear means that points are not on the same line. Okay? So, all right. Let's talk about this over here, the unique line postulate. So it says that through any 2 points, there exists one and only one line. So if I were to connect X and Y, there's only one line that can be drawn in between these 2 points. So one line can be drawn. Okay? Only one line. Okay? One and only one. All right? Okay, so now let's go over here and let's take a look at this problem. And it says that, we have this figure here, okay, and we want to answer these questions. So it says, name 3 collinear points that are on line M. Okay, so line M, first of all, is, I'm going to highlight line M here. That's this line right here. Okay, and 3 points that are on line M are going to be J, K, and W. So I would simply just write points J, K, and W. All right? Okay, and then I want to write and say, on this next one it says, name a point that's not on line M. Okay, and I see 3 of them. I see X, so let me highlight this one in blue. Okay, name a point not on line M. That would be point X, Y, and P. Now, since it says name a point, doesn't mean I have to name all 3, but this means that I have options. So my options would be X, Y, and P. Those would be my points, okay? And then it says how many lines can be drawn between points P and X. So if I were to draw a line between P and X, the only thing that I could draw is one line, okay? How many lines can be drawn between 2 points? And that's just one line, okay? So pretty simple, nothing too terrible, all right? But let's go ahead and move on to the next page. Okay, on this page, let's do this top part and then we'll be done with the notes. So I've got point existence postulate. So a plane contains at least 3 non-collinear points, all right? And we kind of said that before, all right? Objects on the same plane are called coplanar, all right? So what I would do is I would say this, all right? So I've got plane H right here, and I know that that's because this H. And if I were to write down points on that plane, and let's just call this S-A-M, okay, points S-A-M are coplanar because they are on that plane, okay? So not too bad. So I'm going to write that points S, A, and M are coplanar, okay? So another word that comes about this is the word non-coplanar. Okay, and these are points that are not on the same plane, not on the same plane. Okay, and that's it. All right, let's take a look over here. So sometimes that these lines will actually intersect with each other, okay? So if I draw 2 lines, doesn't matter, any 2 lines, they are only going to intersect at one point. And that's what this looks like. One intersection is at that point, okay? Sometimes they have no intersection, okay? And those lines will be parallel. So if I draw 2 lines that never touch, okay, then there's going to be no intersection, okay? And that's when lines are parallel, okay? And so either you're going to have one intersection, if you have 2 lines, okay, you're either going to have one intersection or no intersection, nothing else, okay? All right, let's take a look at this one. Now this one deals with us looking at a 3-dimensional figure, and we're going to take a look at, analyzing this picture and answering these questions, okay? So it says the intersection of plane A, so here's plane A, okay, and plane S, here's plane S, is going to be what? Okay, and when those 2 planes intersect, they form this line here, okay? So on this problem, what I want to do, whoops, let me go to my highlighter, okay, intersection of plane A and plane S will end up being this line here. And if I were to name that line, okay, then I would say either line F, okay, because I see that I have that little 1 cursive letter here next to that line, or I would say that this is line WC, and I would put a line with arrows on the ends, or I could say line CW, okay, and arrows would look like that, okay. So when 2 planes intersect, we get a line. All right, well, that's pretty cool. All right, now on this one it says the intersection of lines N and K. So here's line N. Let me highlight this one here. Okay, so I've got this one. If I were to talk about lines N and then lines K, where do they intersect? And they intersect at this point V. So two lines intersect at point V, okay? And then we'd come over here, all right, and we would say, for the last one, the point X is the intersection of what, all right? So here's point X, and what I notice is that I have this line M, okay, and plane A. Okay, and what this is like a piece of paper with like a pencil sticking out of it. All right, so what I would write is that the intersection of line M and plane A. All right, and that's all we're doing. So it's important that we can, understand what these points, lines, and planes are. So go ahead and get started on your assignment in your quiz on Edgenuity, and we'll see you soon. Thanks a lot. Bye.